Illustrate with an example how to create a thread using thread class and also using runnable interface. There are two ways to create a new thread of execution. One is to declare a class to be a subclass of the thread class. The other way to create a thread is to declare a class that implements the runnable interface. That class then implements the run methods. In this example, how to create a thread using thread class. Class myThread extends thread. This class extends the thread class, indicating that it's meant to represent a thread. It overrides the run method, which is the entry point for the thread's execution. Inside the run method, there's a loop that prints a message and then sleeps for 1 second. Repeated 5 times. Thread example class. This class contains the main method, which serves as the entry point of the program. In the main method, an instance of myThread class is created, and then its start methods is called. This method initiates the execution of the thread, which internally calls the run method of myThread. When you run this program, it will create a separate thread of execution that will print thread using thread class 0 to thread using thread class 4 with delay 1 second between each message. Next is using runnable interface. Class myRunnable implements runnable. MyRunnable class, this class implements the runnable interface, indicating that it defines a task that can be executed by a thread. It implements the run method, which contains a loop that prints a message, then sleeps for 1 second, repeated 5 times. Runnable example class. This class contains the main method, which serves as the entry point of the program. In the main method, an instance of myRunnable class is created. Then a new thread object is instantiated with this myRunnable object passed as a parameter to its constructor. This associates the myRunnable task with the newly created thread. Finally, start method is called on the thread object, initiating the execution of the associated task. When you run this program, it will create a separate thread of execution that will print thread using runnable interface 0 to thread using runnable interface 4 with a delay of 1 second between each message. What is the purpose of join method? In Java, the join method is used to wait for a thread to terminate. When you call join on a thread object from another thread, the calling thread will wait until the specified thread terminates or until a specified timeout occurs. Here, how it works. First is thread equals to new thread, new my runnable method. This line creates a new thread object and associates it with an instance of my runnable by passing it as a parameter to the thread constructor. This means that the run method of the my runnable instance will be executed when the thread starts. Next is a thread dot start method. This line starts the execution of the thread. Once started, the thread will begin executing the run method of the my runnable instance in a separate thread of execution. Next, try block. Under try block thread dot join method and the catch handle the interruption. The join method is called on the thread object. This method blocks the current thread is called and until the thread it is called on the completes its execution. The try catch block is used to catch any interrupted exception that might occur while waiting for the thread to finish. If an interruption occurs, the exception is caught and you can handle it according to your requirements. In this example, ensures that the main thread waits for the thread to finish its execution before continuing with further operation. And next question is that describe the different thread state. A thread is a path of execution in a program that goes through the following states of the thread. 5 states are present. First is new, second is runnable, running, block, and last is dead state. In the new state, first is new or newborn state. When an instance of the thread class is created, a new thread is born and is known to be newborn state. That is, when a thread is born, it enters into new state but its execution phase has not been started yet on the instance. And second is a runnable state. The second phase of a newborn thread is the execution phase when the start method is called on a new instance of a thread. It enters into a runnable state. In the runnable state, thread is ready for execution and is waiting for the availability of the processor or CPU time. There are many threads that are ready for execution. They all are the waiting in a queue. And next is a running thread. Running means processor CPU has allocated time slot to thread for its execution. When thread scheduler selects a thread from the runnable state for the execution, it goes into the running state. In the running state, processor gives its time to the thread for execution and executes its run method. It is the state where thread performs its actual function. A thread can come into running state only from the runnable state. A running thread may give up its control in any one of the following situations and can enter into the block state. When sleep Sleep method is invoked on a thread to sleep for the specified time period. The thread is out of the queue during this time period. The thread again re-enters into the runnable state as soon as this time period is elapsed. And when a thread is the suspended using suspend method for some time in order to satisfy some conditions, a suspended thread can be revived by using a resume method. When wait method is called on a thread to wait for the some time, the thread in wait state can be run again using notify method and or the notify all method. And next is a block state. A thread is considered to be a block state when it is suspended, sleeping or waiting for some time in order to satisfy some condition. And last state is a dead state. A thread dies or moves into a dead state automatically when its run method completes the execution of the statements. A thread is terminated or dead when a thread comes out of the run method. A thread can also be dead when the stop method is called. Thread moves from one state to the another state in the variety of ways. This is because in multi-threading environment, when multiple threads are executing, only one thread can use CPU at a time.